Alright, so y'all go ahead and do the factoring and the math knowledge question. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to do x plus 9 and x minus 2. So that would be your answer there. So for the math knowledge question, the price of 10 pounds of apples is $D. So I want to know what is the price per pound. So our price is $D and the pounds are 10 pounds. So that's our price per pound. But then it talks about down here in cents. So if we have $D, how many cents do we have? If I have $5, I have 500 cents. So I need to multiply that by 100 to put it in terms of cents, which means that this will actually simplify to 10D. So that's your price per pound. And it says 1 pound is 6 apples. So what is the price of a dozen such apples? So how many pounds would we need if we need a dozen apples? We would need 2 pounds. So 2 times the 10D would be 20D. So that would be your answer for your math knowledge question. We're looking at lesson 8 today in calculus. We're going to deal with Pythagorean identities, functions of negative theta, trig identities, cofunctions, and then we're going to look at similar triangles. So this is a bunch of sine, cosine, and tangent stuff that is hopefully going to be reviewed from last year. And then similar triangles, if I taught you, you probably did it in geometry and algebra 2. And we also do it last year, but it's not really a pre-cal concept. It's more of an algebra 2 or geometry concept. So these are your Pythagorean identities. Hopefully you are familiar with them. You may have forgotten them over the summer, but this is the one that you really have to memorize. The other two, you don't have to memorize because you can derive it from this first one. But I definitely think it is helpful if you have all 3 of them memorized. But the first one is the one that you absolutely have to memorize. So I said you could derive the other 2. So the way you do that, you would divide by sine squared on every term. And sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cosine squared. Cotangent squared. And then 1 over sine squared is cosecant squared. It's the reciprocal. So that's how you would get to the bottom. If you wanted to do the top one, then you would divide by cosine squared. And so sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. And then 1 over cosine squared is secant squared. So that's how you can get to those other 2. But frequently are used. Sometimes it's just easier to have them memorized than to have to derive them. But that's completely up to you. Alright, so first example, we want to evaluate sine squared of 17 degrees plus cosine squared of 17 degrees. Do you know the sine of 17 degrees? Or the cosine of 17 degrees? No. We're not needing a calculator for this one. This is a little tricky question. It's just using the Pythagorean identity. Sine squared of any angle plus cosine squared of that same angle always equals 1. So that equals 1. So you didn't have to use a calculator or anything like that. You just had to know your identity and be able to use it, apply it to this question. Moving on to functions of negative theta. The sine of negative theta becomes negative sine of theta. The cosecant of negative theta is the same thing as negative cosecant of theta. Now for cosine and secant, the negatives disappear. For tangent and cotangent, it is just like the top ones. The negative comes on the outside. So cosine is the one that the negative disappears, and for secant, otherwise, a negative angle, you can just pull it on the outside and make it negative sine of theta. So you should have dealt with those quite often in pre-calculus. So we want to simplify this one. as much as we can. So the first thing that we're going to do is to try and get rid of our negatives, or at least make them not negative thetas. So it's going to become negative sine of theta for sine of negative theta. And then for cosine, what happens to the negative on it? It just disappears. So it just becomes cosine of theta. And then for tangent of negative theta, that's going to be negative tangent of theta. And then we have a negative on the numerator and the denominator, so those can cancel. And these are very similar to what we dealt with several lessons ago. We're going to put everything in terms of sine and cosine. So those two are already in terms of sine and cosine. And then tangent is going to be sine over cosine. So that's how we simplify it. And then to go a little bit further, instead of dividing by sine of theta over cosine of theta, we can multiply by the reciprocal. And so now our sines will cancel, and then cosine times cosine is cosine squared of theta. And so that would be your answer for that one. For this next one, it says show that the left side equals 0. So we did show that last year in my pre-calc class. You should have done show that in another pre-calc class if you didn't take any last year. So what you do, pick one side. We can't really deal with 0 very easily, so obviously we're going to want to pick the other one. So you're going to pick it and write it down. And after you have it written down, you're going to start trying to simplify it. So tangent of negative theta is just negative tangent of theta. Cosine of negative theta, the negative disappears to become cosine of theta. And then sine of negative theta is going to be negative sine of theta. That's the first step, is to make the negatives disappear. After that, we want to try and simplify. Well, we can't really simplify this sine here, but we can make it plus sine of theta. Over on this first part though, tangent can be written as sine of theta over cosine of theta. And then we had times cosine of theta, and then plus that sine of theta. And if you look, these cosines will cancel, so that we have just negative sine of theta left, and then plus sine of theta, and that equals 0. And so that is how you would show that. So there's your answer for that one. Basically, your work is all you have to do to show just show your work, and that is to show that for these. Alright, so trig identities. We're going to restrict ourselves to 3 techniques. First, you can substitute equivalent expressions for all or just a part of the given expression. You can make substitutions as needed. Like we just substituted sine over cosine for tangent, because those are the same thing. You can multiply numerators and denominators so that you can combine fractions, but as long as it's not a 0, you can't multiply them by 0. And then you can combine terms that have the same denominators. So if you've got 2 fractions, if you want to make it into 1, you can do that. Okay, so we want to show that these are equal. So again, you pick one side and you write it down. Obviously, the left side is going to be the one that's going to be easiest to simplify because there are more things on it. Sometimes it doesn't matter, but most often it is the left side. So if you're not sure what to do, just pick the left one and try it. And you can always try the other one if the left side does not work. So this is secant of negative x, not secant minus x. Like, that's all one thing. So that's the first step that we're going to do. Write it down. Now we're going to try and simplify it as best we can. Well, if you look in the numerator, what do we notice about cosine squared plus sine squared? cosine squared plus sine squared equals 1. So I have 1 plus 4 in the numerator. And then in the denominator, I'm going to keep the 5 secant squared of negative x. You only want to make one change at a time, so that would be the first step. Going from here, what can we do with secant of a negative x? It's just like cosine in that the negative goes away. So we're going to have 5 secant squared of just x. Now if you notice, the 5's can cancel, and that makes it just 1 over secant squared of x. And so 1 over secant squared is the same thing as cosine squared. And so that is exactly what we have up here. And so this whole thing would be your answer. Okay, so that's how you would do a show that. Hopefully, again, that is review. For this one, we again want to show that they are equal. So we'll start with picking a side, and the left side is the one that requires the most simplification. So I'm going to start by making this secant squared into 1 over cosine squared. Okay, and then if you look, those cancel, so that I have 1 minus cosine squared of x. And so now we're trying to make it equal sine squared. So some of you may know what to do. Some of you may be stuck. So I'm going to go back to the beginning and show you these. This is the one here that I'm going to take this. This is the one that's important for this example. We have 1 minus cosine squared. So if I have a 1 and a cosine squared, I can move the cosine squared over. And what is 1 minus cosine squared equal to? Hopefully you said sine squared, because that is what it equals. And if you look, that's what we have here, so that works. So this would be your answer. So that's how you do show that. You have to know some of your trig identities to be able to do them. They're not necessarily difficult in calculus. They don't get too difficult like they were in pre-cal sometimes. They usually stay a little bit easier. But you do have to know your identities in order to do some of them. Alright, so now looking at cofunctions. Some of you may remember these from last year. Some of you may not remember them. We did cover them last year. Cofunction is just the other angle in your triangle. In a right triangle, you have your right angle, and then this angle and this angle add up to 90. So if this one is theta, this other one is 90 minus whatever that other angle is, theta. So the sine of theta is equal to the cosine of 90 minus theta. I don't know if you've noticed, hopefully you have, the sine of 30 equals the cosine of 90 minus 30, which is 60. Same thing with cosine of theta equals sine of 90 minus theta. Likewise, tangent and cotangent would be your cofunctions if you do the 90 minus theta, and then secant and cosecant. So that's how the cofunctions work. And you need to know those so that you can use them sometimes. So now we have 4 procedures we can use to simplify trig expressions. We can replace negative theta with positive theta. We can replace either 90 minus theta, or if they put it in radians, pi over 2 minus theta with one of the cofunctions that we just looked at. You can use a Pythagorean identity, or you can replace tangent, cotangent, secant, cosecant with sines and cosines. So those are the things that you're going to want to use to simplify your trig identities. So let's look at this one. You want to show that those are equal. So again, pick a side. I'm going to pick the left side. And it combines several aspects all into this one problem. So we're just going to start with the first term. Sine squared of negative theta is the same thing as not negative sine squared of theta. It is not this. And I'm going to show you why. Sine squared can be written out as just a sine and a sine. So we can do two of them right next to each other to multiply them together. And if I pull out the negative on this one, it's going to be negative sine of theta. And if I pull out the negative on this one, it's also going to be negative sine of theta. But negative sine theta times negative sine theta is positive sine squared theta. So on the squares, the negatives actually just disappear, because there are two of them to pull to the front, so they both disappear. Okay, so now for cosecant squared theta minus 1, you're going to want to go back to your Pythagorean identities from the beginning. So I can do that real quick. And we were dealing with cosecant. And so if I pull it right here, cosecant minus 1. Well, if I'm going to make that cosecant minus 1, I'll have to subtract that 1 over. So then it's going to equal cotangent squared. So this whole thing can be replaced with cotangent squared of theta from that Pythagorean identity. Now for this one, cotangent of, this is the same thing as 90 degrees, pi over 2, it's 90 degrees minus theta. Using your cofunctions, that is going to be the same thing as tangent. So that's the first thing you're going to do. Now, we can't simplify any of them individually, so we're going to put them all in terms of sine and cosine. So the first one's already in terms of sine. Cotangent is cosine over sine, but this one is cotangent squared, so it's actually cosine squared over sine squared. And then tangent is just sine over cosine. And so I can simplify that sine squared and that sine squared, and I can simplify one of the cosines here. They cancel out, so that I'm left with cosine times sine. And that is what that equals over there. So that is my answer. All of this work. Okay, so there's another show that for you. Now we're going to move on to similar triangles. So we want to find B on this one. So if you need to break it up into the two separate triangles, you can. If you don't need to, you don't have to. But we're going to set up ratios. So 4 over C equals 6 over 10 equals x over x plus b. So the 10 came from adding the 6 plus 4. You don't multiply those, you just add them together. So that's why it's x plus b. You just add those two together. We're looking for b, but I have to find something else first before I can find b. So I've got an x here. So if you go back over here, what do you notice about this triangle? Can we find x from this triangle alone? Hopefully you said yes, using Pythagorean theorem. So x squared is the square root of x equals the square root of 52, which is 2 square roots of 13. So using Pythagorean theorem, we can find x. Now, I actually don't like to plug it in here because it just makes it a little bit more worky. So if you cross multiply, you get 6x plus 6b equals 10x, and then 6b equals 4x, and b equals 4x over 6, which is 2x over 3. And then we can plug in what our x equals. So 2 times 2 squared to 13 is 4 squared to 13 over 3. So that's your b value. You can go ahead and plug in the 2 squared to 13 here and then simplify it. You'll get the same thing. It just makes it seem harder just because you've got radicals the whole time. So either one of them is fine with me. Notice we didn't ever have to find c. It only asked us to find b. You could have found c using your first two radicals over here pretty easily, 20 over 3, but there wasn't really a reason to find it. Okay, so now we're going to solve for p in terms of h, x, and d. So we're not going to get a number value for our answer. So you're going to make your ratios first. So that's going to be x over h equals p over p plus d. And we're needing to solve for p. So I'm just going to start by cross multiplying. So there is the first step if you cross multiply, and then I need to move p to the same side. So I've got this p over here, I'm going to move to the right. And then I'm going to factor out the p. And then divide by h minus x. And so there is your p value. Very similar to a problem that we did at the very beginning of the year in terms of algebra. Moving on to the next one. Again, we want to solve for y in terms of a, b, and x. So if you set up your ratios, little triangle A over big triangle B, the little side is x over the big side is x plus y. And then you're going to do the same thing, cross multiply. And if we're solving for y, there's only this one y here. So ay equals bx minus ax, and you divide by a. And so there would be your y answer. Again, if I'm going too quickly, y'all feel free to pause the video or go back, rewind it, whatever y'all need to, if y'all need to slow down just a little bit. I'm not in front of y'all to know if I'm going too quickly. Okay, so for this one, we need to find x, y, and z. So if you notice, there are three right triangles. There's this little one here on the left, there's this bigger one, and then there's the really big one. You can try and do similar triangles and turn them all the same direction and work from there, or you can use geometric mean from geometry. I preferred the geometric mean because it's not that difficult to do. You just have to remember your corollaries from lesson, I believe it's lesson 51 from the geometry book. If you want to go look, it may be lesson 50, but I think it's lesson 51. So if y'all want to break and look at the corollaries from that book later, you can do that. So this x is the geometric mean between 3 and 9. And so what that means, you put 3 and 9, and then x goes opposite, diagonal from itself. It's the geometric mean of these two numbers. So then if you cross multiply, x squared equals 27. So if you take the square root of 27, that is 3 square roots of 3. So that's your x value. Now from here, you could use Pythagorean theorem on each of these two triangles to find y and z, but I'm going to go over the other two geometric corollaries just so that you can kind of refresh. Y is the geometric mean, so it's going to go here and here, and it's of the whole hypotenuse and the part of the hypotenuse that is closest to it. So the whole length of the hypotenuse is 12, and it can go here or here. It doesn't matter. And then the part of the hypotenuse that is closest to it is 3. So again, 3 and 12 could switch places. And then you just cross multiply. Y squared equals 36. Take the square root of 36, and that gives you 6 for your y value. Okay? So using the same concept, y'all pause the video and try and find z. Now that you have tried z, it is the geometric mean, just like y is, of the whole hypotenuse, which is 12, and the part that is closest to it, which is 9. So if you cross multiply, z squared equals 108, and if you take the square root of that, you get 6 square roots of 3. So that would be your answer for x, y, and z. So hopefully you kind of remember geometric mean. If not, practice this problem, look back at it. You definitely want to be able to do these more quickly using geometric mean than trying to do it using similar triangles. Alright, so your homework is 1 through 25, so make sure y'all do that tonight so we can go over any questions you have tomorrow.